These are Algebra 1 Notes 4.4, Solving Systems by Graphing. Now, you will definitely need to have your calculator handy, so get that out. And I would suggest you clear the RAM, and you can clear the RAM by hitting the second button and then the plus key. That'll clear your RAM on your calculator. So let's take a look at number 1. It says, use the table on the calculator to determine the ordered pair if the ordered pair is a solution to this system of equations. Check in the table using a calculator. So here is the ordered pair that they've given us right here, 5, 2. And we want to see if that is a solution. Now remember, a solution for a system of equations means it's an x and a y value that will work for both equations at the same time. So in order to use our calculator table to determine this, we want to take our two equations and set them equal to y equals. Okay, so on this first one, I am just going to add y on both sides, so I have 2/5 x, put y on both sides, equals y. These cancel out. So we can just flip that around and say y equals 2/5 x. Okay, and then on the second one, let's subtract 3x. I'm going to do this in a different color. Let's subtract 3x on both sides. And I'm going to take my minus 3x and just tuck it right in front of that 13. So I get negative y equals negative 3x plus 13. Now we don't want it to say negative y equals, we want positive y. So we need to divide everything by -1, and when we divide by -1, the only thing that changes is the sign. So the negative y becomes positive y, the negative 3x becomes positive 3x, and the plus 13 becomes minus 13. Okay, now that I have these equations, we are going to take these two equations and put them into y1 and y2 in y equals, and then go to your table. So I took a picture of my calculator where I put my two equations into y equals, and you can see that right here. And then I use second graph to go to the table, and here's my table here. So let's go ahead and fill in the points that we're asked to. So we're supposed to do 3, 4, 5, and 6. So we have 6 over 5. This is for the first equation. 6 over 5, 8 over 5, then 2, and then 12/5. And for the other one, we have -4, -1, 2, and 5. And so I'm just taking these values from the table, and we can see right here where x is 5, y is 2 for both equations, so indeed it is a solution. Okay, let's jump down to the bottom. So in number 2, it says solve each system by graphing, and it says graph by hand. So we're not going to graph this using our calculator. You could use your calculator for the table to fill in some points, but we're going to actually plot the points and use a ruler or your badge or something with a straight edge to draw your lines. So I picked some points for myself to use. I'm going to use -4. I'm going to use -2, 0, and 1. Those are the 4 points I picked. And so I'm going to hit pause. You can plot your points and graph your line while I do the same, and then we'll come back here in just a minute. So get that done. Plot your points and graph. So you can see here I took the first equation, y equals x, and it's in green, and I plotted my 4 points and drew the line. And then the second equation, negative 2x minus 3, I plotted those 4 points, drew a line. And now it's asking, what is the solution? Well, the solution is where the two lines meet, because this is the one point, the x and the y value, that's the same for both equations. And so that point is at negative 1 comma negative 1. And so that's your solution for the system. Okay, on the next one, it says, which of the following is a solution to this system of linear equations? Well, on this one, it's maybe a little more challenging because we're going to have to figure out the slope of these lines. So I'm just going to use rise over run, and I'm going to go, I can see that it's going up 2 and then over 4, or up 1 and over 2. So it has a slope of 1/2. But I'm going to continue to go up 2 over 4, put a point, 2 over 4, and place a point. Oops. And continue 2 over 4, place a point, and then I'm going to take this line and extend it like so. And then we're going to do the same thing with this line above here. I'm going to go down 1 and over 5. So I went 1 over 5, negative slope, negative 1 over 5, and then extended the line until they intersected. And you can see they're intersecting over here at this point, which is at 10, comma 2. And there's your intersection point. Bam. Okay, now on the back side, we're going to use our calculator to graph and find the intersection points. So you've got to have it ready to go. So let's flip over to the back. So on the top of your paper, you can see the steps that we're going to use our calculator when solving systems. So it tells us both equations need to be solved for y, meaning they need to be in y equals mx plus b or slope-intercept format. Then you have to put each equation into y equals in your calculator. Then you're going to have hit the graph button, and you need to be able to see where the lines intersect. So if they happen to graph like this, I'm going to just make a drawing. Let's say it goes like that and goes like that, and you cannot see the intersection point, then you either need to go to your window and change it or hit zoom and then number 3 to zoom out and then enter to back it up. Then once we see the intersection point, then we're going to use the second trace and then number 5, which is intersection, and you can just punch the number 5 button on your calculator, and then we're going to do enter, enter, enter to get the intersection point. So let's try it with number 4. And I have pictures of my calculator to follow along, so let's give it a try. So our first equation on number 4 is already solved for y, but the second one is not. So we are going to have to subtract 1/3 x on both sides, and we get y equals negative 1/3 x minus 1. Now that we have the two equations solved for y, we can put them into y1 and y2 in your calculator. So go ahead and do that. So your calculator should look something like this. Next step, hit your graph button. Now, if you cleared your RAM at the beginning, as I mentioned, this is doing exactly what I demonstrated just a moment ago. You cannot see the intersection point of the two lines. It's off the screen. So you can hit your zoom button and hit number 3 for zoom out. And when I'm doing zoom 3, I don't like to use the arrow buttons. I just like to hit the zoom key, punch the number 3, and then hit enter. Zoom 3, enter. And once you do that, you should get this screen. And you can see that now we can see the intersection point there. Now what we need to figure out is what is the intersection point, and that's where we're going to use the next step, which is the second trace 5. So I'm going to show you that on my computer screen too, calculator screen I mean. So when you hit the second button and then the trace button, this is the screen that comes up, and you just want to punch the number 5 key on your calculator for intersection. And then we're going to hit enter, 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 and until the solution pops up. So when you do second trace 5, enter, 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 you'll get a solution right here, 11 and 25 100ths and negative 4 and 75 100ths. So our solution to number 4 is 11.25 is the x, and negative 4.75 is the y. And you did that with your calculator. Bam! Okay, we're going to try it again. I know it's a little cumbersome, especially with all these pictures, but we're going to try it again, and once you do this a few times, you'll get very good at it, and you'll be able to do it very speedily. Okay, so let's try number 5. Okay, so remember, the first thing we want to do is make sure our equations are set with y equals. So we're going to add 1.6. Oh my gosh, losing my mind there. 1.6x. Add that to both sides, so we have y equals 1.6x minus 5.34. Now, once you've got that, let's go to y equals in your calculator, and you can put one of them into y1 and the other equation into y2. So your calculator should look like this. And now that you have that, let's hit your graph button. Hit graph. And when you hit graph, you can just barely see the intersection point of the line. Now, if you left your calculator in zoom out mode, yours might look a little differently than mine. Yours might be squeezed in a little more, and you can see your intersection a little bit higher up. But I can see the intersection point, so as long as you can see that, now you can use the steps. You're going to hit your second button, then the trace button, then you're going to pick number 5 for intersection, and then enter, 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 till we get an answer, a solution. And that's what I did right here, and I got my solution is negative 2.4 and negative 9.18. So let's write our solution down on our paper. Negative 2.4 is the x value, and negative 9.18 is the y. Those are the two values that, when used in both equations, will make them come out true at the same time. Okay, now we have 2 more to go and we'll be finished. Okay, on number 10, we again need to get these equations so that they're solved for y. So on the first equation, I'm going to subtract 4x, and I get negative 2y equals negative 4x plus 4. And now we divide everything by negative 2. And we get y equals these two negative signs right here. When you have 2 negatives, that makes a positive. Do not leave 2 negatives on a fraction. If you see those, you know it's positive. And then positive 4 divided by negative 2 is negative 2. Okay, so there's our first equation. On the second one, all we need to do on this one is divide each side by 2, and we get y equals 2x. Now, we can put this into y1 and y2 in your calculator and hit graph. But before you do that, what do you expect to have happen when you graph that? What do you notice about the slopes of these two lines? They are the same. And since they have the same slope, what would you expect your graph to be? And I hope what you're saying is the lines should be parallel. And you can see here from where I plug these into my calculator, there they are in y equals. Then I hit the graph button, and here's my graph. And sure enough, we have two parallel lines. Now I want you to think about this. We have determined that the solution to two linear equations is where they intersect. And where are two parallel lines going to intersect? They are never going to intersect. So when you have two parallel lines and you're asked for the solutions, there is no real solution for parallel lines. No solutions when they're parallel. Okay, let's do number 11 and we'll be done. So again, we want to solve this for y. So I'm going to subtract 3x. So I have negative y equals negative 3x plus 2. And when we have a negative sign out there in the front, we want to divide by negative 1. What happens when we divide by negative 1? All the signs change. The y became positive, the negative 3x is positive, and the positive 2 is now negative. Now let's solve the other one for y. I'm going to subtract 12x on both sides, so I have negative 4y equals negative 12x plus 8. And now we're going to divide everything by negative 4. And I get y equals 3x minus 2. Uh-oh. Not only are our slopes the same on this one, but the y-intercept is the same. So what do we know about these two lines? They are exactly the same line. If you were to graph them, which you can go ahead and do on your calculator, but when you do, you won't even be able to see them both because they are going to graph right on top of one another, kind of like that. And if you made the second one thick, it would go right over top. They would be right on top of each other. So where are all the solutions on that one? What's the point where they are the same? Well, all of them are the same on these lines. So we are going to say there are an infinite number of real solutions. Infinite real solutions, or all real numbers. Every point on those two lines is the same. So there you go. I hope you learned something. Remember, when we have lines with different slopes, we're going to have one solution. Lines that are parallel, no solutions. Lines that are the same, if I have one like that, and then I have another one that goes right on top, then we have infinite solutions. And let's just quickly review the steps for using your calculator. Make sure your equations are in y equals. Put one of them in y1, the other one in 2. Hit graph. Make sure you see the intersection point or zoom out if you don't. Then use second, trace 5, enter, 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 and you will get the intersection point that solves both equations at the same time. Okay, so there's your lesson. Hope that's helpful to you, and we'll see you in class.